In this video, we're going to look at two-tailed tests for the binomial distribution. Let's take an example. Over a long period of time, it has been found that in Enrico's restaurant, the ratio of non-vegetarian meals to vegetarian meals is 2 to 1. In Manuel's restaurant, in a random sample of 10 people ordering meals, one ordered a vegetarian meal. Using a 5% level of significance, test whether or not the proportion of people eating vegetarian meals in Manuel's restaurant is different to that in Enrico's restaurant. So what we ought to do first of all is to set up our hypothesis, and our null hypothesis will state that the probability will remain as 1 over 3. But the alternate hypothesis will say, well, we don't know whether there's an increase or a decrease, or a change or a difference. So what we say is, we say it's not going to be equal to a third. And this will always be the case when it's a two-tailed test. So we say it's a two-tailed test. But when it's two-tailed, we half the level of significance. So we half 5%. So we get 0.025. So if we now go to the question, we can now say, what's the observed value? Well, out of 10 people, and a random sample of 10 people, one ordered a vegetarian meal. So this one here is going to be called our observed value. So what that means is we've seen at most one person ordering a vegetarian meal. So don't forget, binomial is a cumulative distribution. So we say the probability that x is less than or equal to 1. So what we can do here is we can say, well, we can get this value from our calculator. So we go to menu, 7, go down to binomial CD, variable, x is less than or equal to 1. Remember, it's always less than or equal to 1. Our number is going to be 10. And our probability is 1 divided by 3. So that will give me 0.1040. 0.1040 to 4 decimal places. And don't forget, we can say x follows the binomial, where we have 10 people and the probability of ordering a vegetarian meal is a third. That's our binomial model. And we can define our random variable as the following. I'm going to write that here. Let x represent the number of people who order a vegetarian meal, That's called defining our random variable. And we've got our binomial model as x follows the binomial of n being 10 and the probability being a third. So now what we're going to do is we're going to compare our p-value, which is 0.1040, to our significance level. And remember, if your p-value is less than 0.025 or less than alpha, that will be the criteria to reject the null hypothesis. But in our case, it's greater than, so we say since 0.1040 is greater than 0.025, we say the following: we do not reject H0 at the 5% level of significance, and we say we have insufficient evidence to suggest that the proportion of people eating vegetarian meals in Manuel's restaurant is different to that in Enrico's restaurant, to that in Enrico's restaurant. And that's how we write our conclusion for the examiner. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So this question states, a machine makes glass bowls, and it is observed that 1 in 10 of the bowls have a hairline crack in them. The production process is modified, and a sample of 20 bowls is taken. One of the bowls is cracked. Test at the 10% level of significance the hypothesis that the proportion of cracked bowls has changed as a result of the change in the production process. State your hypotheses clearly. So first thing we ought to do is to write our random variable. So we're going to say let x represent the number of bowls which are cracked. So now what we can do here, we can now say that x follows the binomial of, well, we have 20 bowls. Now 1 in 10 is cracked, so that's going to be 0.1. And don't forget, it's a change. We want to find out the change, so it's a two-tail test. So the level of significance is 10, but we need to half it, so we get alpha will be 0.05. So now what we do, we need to set up our hypotheses. So we say H0, the probability remains the same, there's no change. And our alternative hypothesis is that P is not equal to 0.1, meaning that we don't know whether there's a decrease in the probability or an increase in the probability, hence a change. So now we're going to go back to the question and say, well, what is the observed value? So we can get our pen and say, well, they say one of the bowls is cracked. This is our observed value. So I'm going to put a little an asterisk here and say this is our observed value. And I'm going to make it very clear that that is going to be at most 1. So we know what that means. So what we're going to say is that the probability is going to be less than or equal to 1. So now what we're going to do is say that the probability that x is less than or equal to 1, we can use our calculator like so and say, well, it's 1, so less than or equal to 1, n is 20, and our corresponding probability is 0.1. So now we're going to get this 0.3917. And remember that if the p-value is less than the significance level, we would reject the null hypothesis. So now we say since 0.3917 is greater than 0.05, we now conclude that we do not reject H0 at the 10% level of significance. And we say we have insufficient evidence to suggest to suggest that the proportion of cracked bowls has changed. And we're done.